All right, good morning. I'm 0xmonsoon. I'm a security researcher at OpenZeppelin. I'm also a member of SEAL 911. And today I'll talk about pull oracles, how to integrate them, what are they, and some security considerations when you're building or architecting your protocol, and some tips. This could also be useful for auditors, but this is mostly meant for developers. All right, let's start. So blockchains are very good when you only have to deal with intrinsic data. So they're basically a computer, a database without any internet connection. So you cannot access external data. There's no post methods or get methods in blockchains. So the problem is if you're building apps for normal users, you'll have to get data from outside. There's tons of data available natively in blockchains, but that would mostly be balances of users, token prices using AMMs. But if you have to imagine build a stock market mirroring platform, you'll have to use an oracle to get those stock prices from outside. If you're building a lending market, let's say you'll have to get asset prices. If you're building a prediction market, you'll have to use an oracle to actually get the data transmitted to the blockchain, what the outcome of that event was to close the prediction market. So that's the problem we're dealing with, getting data to the blockchain, because that makes it more useful for everyday users. So there have been multiple ways people have been trying to get external data to the blockchain. It all started with push oracles. Then slowly different other types of oracles also came into the picture, like on-chain oracles, and most recently pull oracles. So let's first start about push oracles and how they work. So a push oracle is very simple. What happens is whenever a user needs to interact with an app, they just send a transaction to the app smart contract, and that in turn reads data from the Oracle smart contract. The responsibility of updating the Oracle smart contract is with whatever Oracle network you're using. So let's say Chronicle or Chainlink, they'll continuously update the prices or whatever other data you're using in their Oracle smart contract, and you can directly just call this. So push oracles are basically the oldest. It started with Chronicle. That was the first push oracle. Then Chainlink came into the picture, and tons of other ones. And they are responsible for the most TVL secured. They are the easiest to integrate with, because all you need to do is call a certain smart contract with their interface, a specific function of a certain smart contract, and you could get the data. And yes, so basically this makes it very easy to integrate. Like all you need to do is just call a certain smart contract. But the problem with push oracles is it's very expensive to operate, because someone needs to bear the transaction cost of continuously updating the push oracles. Push oracles actually work on either price deviation thresholds or time thresholds. So the data on the Oracle smart contract will be, let's say, updated every 1 hour or something, or if let's say, the price deviates by 5% or something. So the Oracle network constantly needs to send transactions to the smart contract for every data feed that they have on every network. So it makes it very hard and very expensive for them to support a lot of different data feeds on a lot of different chains. So let's come to what are pull oracles. So what happens when you use a pull oracle is the end user themselves are responsible for transmitting the data or price, whatever you want to use, onto the blockchain itself. So what happens is, imagine I'm a user and I want to interact with a app, with a dApp. So I'll first get the price from the Oracle network or server. I'll retrieve the price from there. I'll bundle it with my transaction, and I'll send it to my app smart contract, whatever app I'm going to use. And that app will verify the data, whatever the price load is, the payload is, using the Oracle Network smart contract, or it verifies it internally. There are two different modes. We'll talk about it. So the benefits of using a pull oracle is it can support a higher number of chains and pairs, because the Oracle network isn't responsible for transmitting the data, so it doesn't have to bear the cost. The cost rests with the user. So pull oracles are can be classified in two ways, by either execution patterns or by the payload validation method. So sometimes some types of pull oracles have atomic execution. So you deliver the price in the same transaction where the transaction is supposed to be executed. So let's say I want to borrow from a lending protocol. So I'll give the price of all the assets in the same transaction, and I'll also borrow in the same transaction. So the execution happens atomically. Then there's also another pattern that's in which the execution is deferred. So what happens is I'll intend to the dApp smart contract that I want to make such a certain transaction. Let's say I want to open a position on a certain market. So I'll send a transaction indicating so. The app will record that I want to make this transaction, and it will emit an event with all the data fields. Then anyone can act as a resolver and send a transaction in the next block with the price. What this helps with is it prevents front running. So this is popularly used by GMX, so that the transactions that users send to GMX aren't front run. Then we can also classify pull oracles by the payload validation method. In some types of pull oracles, when you send an update payload, they are externally validated by an external smart contract, which is usually the Oracle Network smart contract. So if I send an update payload to a dApp, the dApp will in turn call the Oracle Network smart contract, and that will validate the payload. There's another way in which you can internally validate the payload. Some pull oracles support this, in which you basically integrate a library. You do this by inheriting their smart contracts, and the library smart contracts basically validate all the signatures that you have sent, and if a certain threshold is met, the price is validated for you. So this basically gives us like 4 types of pull oracles. So like Pith is an example of a pull oracle that's externally validated by the Oracle network itself, but supports atomic execution. The Chainlink data stream used by GMX is an example of externally validated pull oracle, in which the execution is deferred. So the price is transmitted to the blockchain in another transaction and not in the same one. Then you have internally validated pull oracles. So Redstone is a prime example. So the Redstone pull oracle supports atomic execution, and the Redstone X works just like Chainlink data stream, and it supports deferred execution. The only difference is you have to inherit the smart contracts of Redstone to do the validation inside your dApp itself. So this is pseudocode, basically to integrate Pith. So as you could see in this example method, there are some inputs by the user, let's say the user address and amount. But you will also notice another argument, which is an array of bytes call data price update. So basically, this is an array of all the price feeds you want to update. So updating price feeds on Pith can require sending them the native token of whatever blockchain you're on. So basically, in the first line, you get whatever the update fees is, and then you call the Pith, the smart contract of the Pith network, and call the update price feeds method, send them a value, and then in the arguments, you send them the price update array. You do this because Pith actually caches the price for some amount of time. Probably it's 3 or 5 minutes. So you can actually call the Pith smart contract just like how you'd call a push oracle smart contract. But if the price is stale, the call will revert. So it's always better to just update the price and then read it by calling. There are multiple functions to get price. The recommended one is to get the get price no older than function, pass in the price feed ID, which is a bytes 32 argument, and then the number of seconds. Right? So this is how you would also use Chainlink data stream. The only difference would be first you will actually get your transaction stored in their smart contract, in the dApp smart contract that will emit an event, and people will anyone can observe that event and resolve it by calling another function in your smart contract and delivering the price, and then your smart contract will verify it with Chainlink. This is how you integrate the Redstone oracle. Basically, you import their contract and then just use a function they have called get oracle numeric value from transaction message, and you pass in the data feed ID. So to use Redstone, their price update payload is appended at the end of the call data. So you'd see there's no bytes array here. It's appended at the end, and it automatically fetches as using assembly. All right, so things to keep in mind. So when you're using pull oracles, they are updated very frequently, like sometimes multiple times a second. So one problem could be that the timestamp of the price update can be from the future. So it could be greater than the block.timestamp. So if you're making an assumption that the price update timestamp will always be less than equal to block.timestamp, this may not hold and may cause problems. And this can also be problematic if you're mixing block.timestamp and the Oracle update timestamp in the accounting and business logic of your contract. If you're using any Oracle where you have to internally validate the data, make sure you are doing sufficient validation on the price update payload, because if you're not validating that, people can use past prices. So always validate that the price delivered to a smart contract, the timestamp is always higher than whatever was delivered before. because we've seen this in audits before where protocols have implemented this in a very buggy way. Also, if you're using any Oracle which internally validates the payload, make sure that in the same block, you do not revert if anyone sends a payload with the older price timestamp, because that could result in a DOS for that user. So in the same block, always remember, do not revert if an older timestamp comes. Just return at that point and do not change the price. Another problem with pull oracles is there can be multiple prices in the same transaction, because all I need to do is provide the smart contract with a timestamp that's greater than the last updated timestamp. So if my dApp or the Oracle Network's smart contract was last updated yesterday, I could use all the prices since yesterday to today, and then I can use them in the same transaction. And I could use them in a malicious way. And even if the difference between the prices is small, it can be amplified by using flash loans. Remember, this all is happening in one transaction, so you have the luxury to use flash loans. So if you're making perpetual or future protocols or synths, and you allow atomic minting and burning of synths, attackers can use this to drain part of your funds. Plus, if you plan on making an immutable protocol, using internally validated pull oracles can be problematic, because they use public keys of signers to see if whether the payload has a sufficient certain threshold of signers or not. So if the private keys of those signers gets compromised, there's no way for the Oracle network to actually update it without you having to upgrade your smart contracts. In case of externally validated pull oracles, this can be done. But internally validated pull oracles, this is not possible. If your protocol is immutable, you'll have to upgrade it. Plus, if you plan on using multiple types of oracles in your protocol, let's say a push oracle, different types of pull oracles, you'll notice you cannot use the same function signature for all of them, because different types of pull oracles would require different encoding methods. A push oracle does not require you to send prices along with it. So you'll actually have to abstract away the price extraction mechanism into a separate price oracle or asset oracle contract, and you'll have to have a contract for each asset you want to obtain the price for. So what will happen is you'll have to make multiple calls. Imagine if I want to borrow something, I'll first have to call that asset oracle contract, update the price, then I'll have to call the borrow function in the main contract. So this could cause compatibility with EOAs, because EOAs cannot make multiple calls by default. So to allow the EOAs to make multiple calls, you'll have to use a multi-call, and you'll have to add some authentication functionality to it. So you call the EOA can call the multi-call, update the price, and then call the borrow function of the main protocol. And the protocol can rest assured that the user was authenticated by the multi-call, so it can be trusted, because the message.sender for the protocol would be the multi-call address. And this is how Euler does it, using their Ethereum Vault connector, which is basically a multi-call with authentication in it. So can older protocols that were made before pull oracles and were made function with push oracles, can they be integrated with pull oracles? Let's say compound v3. And actually, the answer is yes, because compound has some special functions that allows anyone to operate on behalf of a user. So it has supply from, transfer asset from, and withdraw from functions. And the liquidate function does not require the end user to be the message.sender. So a multi-call can actually do everything on the behalf of a user, on the behalf of a EOA, and can also update price. So that's it mostly from me. If you want to learn more about oracles and different types of oracles, you can look into OEV oracles. Basically, OEV is a subset of MEV, but it revolves around the extractable value whenever an oracle is updated. So like Oval and API3, you could read into that. You can read into ZK oracles and hybrid oracles too, which is basically a hybrid of push plus pull used by synthetics. So yeah, that's it from me. Any questions? Yes, please.
Thanks. So in your example about Pith Oracle, which is atomic, I was just curious to know how it's possible to call the update function, then have the off-chain Oracle updating the price and getting the price, if it's what I've understood.
I'm sorry, can you repeat that?
How is it possible for an off-chain service, like the price Oracle, Pith, for example, to update the price atomically, if it's how it's working?
That is possible, but that would actually make it a push oracle if there's a service that updates the price if at a certain interval, right?
Thanks.
Yes, please. All right. Thank you, guys.